For our subject, data science in healthcare, we'll focus today on the introduction part. Why do we use data science in healthcare? We'll be referring this textbook by Chandan Reddy actually. Yeah, this is the book we are referring today for this video. What it says is, this book says we can incorporate current healthcare technologies to reduce mortality rates, healthcare costs, medical complications. So, US government in 2009 enacted an act called as HITECH, which stands for Health Information Technology for Economic and Clinical Act, which includes an incentive program worth $27 billion for the adoption and meaningful use of electronic health record. So big data is a good potential source for healthcare data, and it can reach up to $300 billion worth. We also have advances in data sensing and acquisition technologies. So hospitals, healthcare institutions are collecting this healthcare data through these data sensing and acquisition technologies. So understanding this data, getting the insights about this data will further enhance the healthcare domain. Data analytics plays a critical role among the computing technologies in healthcare sector. When we apply the analytical solutions to healthcare data, it will help in transforming healthcare delivery from being reactive to being more proactive. Healthcare data is heterogeneous. Healthcare data is derived from sensors, images, specs, in the form of biomedical literatures, chemical notes, traditional electronic records. So, this heterogeneity is a challenge for processing and analysis of this heterogeneous data. So you also have various techniques for handling such heterogeneity. So we also will be facing data integration and data analysis challenges because of this heterogeneous data. A major challenge in healthcare is it is interdisciplinary. Another major challenge in healthcare is data privacy gap between medical researchers and computer scientists. Healthcare data is very sensitive. It has compromising information about individuals. So there are many laws in different countries, such as HIPAA, Health Insurance Portability and Accountability Act in the United States, which will forbid the release of medical information about individuals for any purpose unless safeguards are used to preserve their privacy. Data acquisition is not as simple because of this heterogeneity, and as well a lot of collaboration with medical practitioners is required. Coming to the healthcare data sources and basic analytics, one of the major healthcare data sources is electronic health records. These are the digitized versions of a patient's medical history. They may specify demographics, problems, medications, physician's observations, vital signs, medical history, laboratory data, radiologic reports, progress notes, billing data. EHRs are designed to be in real time, and they can instantly be accessed and edited by authorized users. The storage and retrieval of health-related data is more efficient using electronic health records. It helps to improve quality and convenience of patient care, increase patient participation in the healthcare process, improve accuracy of diagnosis and health outcomes, and improve care coordination. So we are listing out what? Healthcare data sources. The first healthcare data source is electronic health record. The second healthcare data source we are mentioning is biomedical images. So medical imaging, which are the common example of medical imaging? They are MRI, magnetic resonance imaging, CT, computed tomography, PET, positron emission tomography, US ultrasound. The final goal of any biomedical image analysis is to be able to generate quantitative information and make inferences from the images that can provide far more insights into medical conditions. The next healthcare data source is sensor data analysis. So what are the examples? ECG, electrocardiogram, EEG, electroencephalogram. Now take the case of ICUs. So in ICUs, we use hundreds of sensors for various data sources, recording and alarms triggering in real time, because it is a critical aspect whenever a patient is in ICU. So that will lead to the usage of big data frameworks and specialized hardware platforms. If the patient is remotely being monitored, the real-time events, long-term analysis of various trends and treatment alternatives is of great interest. The next healthcare data source is biomedical signal analysis. The examples are ENG, electromyogram, EMG, electromyogram, ECG, electrocardiogram, EEG, electroencephalogram, EGG, electrogastrogram, PCG, phonocardiogram. The processing and interpretation of these signals is challenging due to low signal to noise ratio and interdependency of physiological systems. We can use various techniques for filtering these, removing the noises. We may use dimensionality reduction techniques such as PCA, that is principal component analysis, SVD, that is single value decomposition, and wavelength transformation. The next source of healthcare data is genomic data analysis. Here we are speaking about genetic. So we all know that many of the diseases have genetics role play, whether it is diabetics or whether it is blindness or many more diseases. So we need to have a better understanding of genetic markers, mutations, disease conditions, which will help us in giving better treatment, doing gene therapies to cure the patient. The next healthcare data source is clinical text mining. So we have clinical notes for every patient. So they may be an unstructured format, they may be handwritten notes, they may be voice notes, they may be tabular data. So again, heterogeneity comes into picture. So they may be transcriptions of dictations, there may be direct entry by providers, there may be use of speech recognition applications. So here, natural language processing and entity extraction play an important role in inferring knowledge from these large volumes of clinical text to automatically encode clinical information in a timely manner. The next source of healthcare data is mining biomedical literature. So the text mining techniques will be used for preserving, accessing, using the digitally available resources in biomedical applications. They'll be relying on the scientific literature, biomedical literature. So text mining techniques and tools will be used on these to derive new knowledge in the biomedical field. One of the major challenges in biomedical text mining is multidisciplinary nature of the field. Okay, for example, you have biologists who will be describing chemical compounds using brand names. You may have chemists who will be using IUPAC compliant names or unambiguous descriptors such as international chemical identifiers. So these challenges need to be catered. The next source of healthcare data is social media analysis. So a significant amount of public health information can be gleaned from the inputs of various participants at social media. So with this, I'll be stopping here. Thank you.